Hi guys! So today we're carrying on with looking at completing the square, so the second half of lesson 4.3. So just kind of review what we looked at in the last lesson. Let's solve x squared plus 8x minus 3 by completing the square, and again we're asked to leave the answer as a simplified radical, which as I mentioned could also be referred to in a test as an exact value or an exact solution. Okay, so with completing this square, we want to have our equation set equal to 0. So, So then I throw in an equal sign. Good job. Okay, so x squared plus 8x minus 3 equal to 0. And then remember what we want to do is isolate those first two terms, and we want to complete the square, right? Which means we take the last term in our isolated set here and divide it by 2 and then square it. So basically we're going to have x squared plus 8x, and then half of 8 is 4, and if we square that it's 16, so then we want to add 16. Remember, we have to always balance out. We can't just add 16 into the equation, so we also need to subtract it out, and then minus 3, and that's all equal to 0. Okay, so the next thing we want to do is we want to make this trinomial into a binomial. So we can basically move this 16 outside of the bracket, and then, well, I'll make it into a couple of steps here to keep it straightforward. Plus 16 equal, or I don't know why I keep throwing equal signs in there. Minus 16 minus 3 is going to be on the outside, so negative 16 minus 3 is going to give us minus 19, and set that equal to 0. Now I can make this into a binomial by finding the square root of the last number. So square root of 16 is plus or minus 4, and then I need to decide whether it would be positive or negative depending on this number. So two positive 4s add to make positive 8, so that means my binomial is going to be x plus 4 squared is equal to, because what I want to do now is move my 19 to the other side so that we can start to work on isolating this x. So if I have negative 19 here, to move it over I need to add 19 to both sides. So I'm going to have is equal to 19 on this side. And now I want to start looking at isolating x, so just basically going through the standard set of algebraic steps that you would use to get a variable on its own. So first always we look at exponents, and so we want to get rid of that square by square rooting it, and then we have to do that to the other side as well. So then we're left with x plus 4 is equal to, and once you have a value, like there's not an even square root for 19, so we want to leave it as a radical, and once we get to that point, that means we have to have plus or minus the square root of 19 there. Then we want to move this 4 away from the x, so because it's plus 4 we need to subtract it from both sides, so we end up with x equals negative 4 plus or minus the root of 19. And that is our final answer that's left in simplified radical form. Okay? Alright, so let's move on with another example of completing this square. This one is a little bit more complex because it's going to involve some fractions, and of course it's a good idea for you to be comfortable with working with fractions, so I wanted to make sure I included an example like that. So in this one we are looking for the roots of negative 2x squared minus 5x plus 2, and then verify your answer using technology. So a lot of times this is something you'll see on a test because I want to see that you can basically like factor out an equation using one of the techniques we've looked at. That's going to be like algebraic, and then you just confirm your answer using technology. So basically by plugging this into your graphing calculator and making sure that your answer is correct. And I didn't really talk about it a whole lot in the last like in the first part of this lesson, but you should, as much as possible, if you can, check on your calculator when you're in a test scenario. I would definitely recommend doing that. However, just be careful that if it asks you to show work, that you're not only reliant on using your calculator to find those answers, but you can definitely use it as a way to check. Okay, so we want to determine the roots of negative 2x squared minus 5x plus 2. And we're going to use completing the square for this one because that's what we're looking at. You could use other methods, of course, but we want to focus on this method for this lesson. So the first thing we want to do is we want to try and eliminate this a value. So we're going to divide it out. Our formula is equal to 0, and so, or rather our equation. So we can divide out this -2, and then we can divide it out of the other side. So remember, if you divide this out and there's nothing over here to divide it away from, then you would have to like make up for dividing out this value later on. But we can divide this out of both sides so that we're left with -2 divided by -2 is +1, and so we're left with x squared. -5 divided by -2 gives us +5/2. Let's leave it as a fraction, okay? So if you put that in your calculator, you're going to get 2.5, but I want you to try and practice using full fractions because that's how you're going to be able to leave an exact value answer when you're asked for that on a test. Okay, and then +2 divided by -2 is -1, and 0 divided by -2 is 0. So there is our new formula that we're going to work with. So now we need to work on completing the square. So remember, that means we're going to isolate our first two terms, right? And what we always want to do is find half of this first value and then square it in order to solve for the value that will complete the square. So this is where it gets a little bit trickier with fractions. So we want to find half of that. So basically we're doing 5/2 divided by 2. Now remember, when you're dividing by 2, basically what that means is it's the same as multiplying by the reciprocal, right? So when you divide a fraction by a number, it's the same as multiplying it by the reciprocal, which makes it a lot easier to do. So when we say 5 divided by 2, technically what we're doing is we're saying 5 divided by 2/1 if we write them both as a fraction. But it's the same thing. This is usually a lot more complicated than, and that's why we kind of talk about that it's the same as multiplying by the reciprocal, is because it's a lot easier to then say, okay, well, that's the same thing as taking 5/2 and multiplying it by the reciprocal of 2/1. So the trick with this always for students, I think, is remembering that if you're dividing by a whole number, that whole number can always be written as a fraction just by putting it over the number 1. And then when you multiply by the reciprocal, you're basically just swapping out the top and the bottom. So it's the same as multiplying by 1/2, right? And so when we multiply fractions, things are really easy because we just multiply straight across. So 5 times by 1 is 5, and 2 times by 2 is 4. So there's our new fraction. Okay, now that I know that seems hard because I had to explain it, but actually it's not that long if you know the math. So now you found half of this value, and remember, then you need to square it to get the complete square. So we need to square this value, which basically means we need to multiply it by itself, 5/4. And remember, like I just mentioned, with this fraction, you just multiply straight across. So 5 times 5 is 25, and 4 times 4 is 16. Okay, so we want to leave this fraction as it is, and we can use that to complete our square. So we have x squared plus 5/2x plus 25/16 that we just calculated. And then remember, of course, we have to subtract that off, minus 25/16, and then we have the -1. And we can set all of that equal to 0. I think I'm just going to get rid of this page number so I don't have to worry about running into it. Right, okay, so now, again, we don't have anything that's being multiplied by this, so we can just kind of pop that one outside of the brackets. And we can combine these terms if we like, and we can start to look at simplifying this. So basically, remember, in order to determine your two values that will make up your binomial, you square root the first term, so x squared is going to be x, and then you square root this second term. So when you square root a fraction, 25/16, basically what you want to do is just square root each number separately. So the square root of 25 is 5. The square root of 16 is 4. So this is going to be our fraction that we're going to use here. Now, because all of our values are positive, we know it's going to be plus 5/4. and then our bracket is going to be squared. So just like with any other number, we treated everything exactly the same as we would for any regular whole number that we're kind of more used to dealing with. Now we want to subtract off negative 25/16 minus 1. Well, how can we do that? This is another kind of fraction rule that you need to remember, which is that when you add or subtract fractions, they need to have the same denominator. So if we want 1 to be the same denominator as this, it would be, so remember any whole number written as a fraction is 1. So if we want to make this have the same denominator, we need to multiply this by 16. So that's going to give us a denominator of 16. And if you do something to the bottom of a fraction, you need to do it to the top exactly the same so that you're not actually changing what the number value is. So it's going to be 16 over 16. And that makes sense, right? Because you can always double check if you did it properly by putting into your calculator 16 divided by 16, which should give you 1. Okay, now we just have to be careful because this is going to be a negative 16 over 16. Okay. So we have minus 25 over 16 minus 16 over 16 is going to be equal to 0. Now we want to start moving these values across to the other side. So you're going to want to put into your calculator and then negative 25 minus 16 gives us negative 41. So we're going to have x plus 5 over 4 squared is equal to negative 25 minus 16 gave us negative 41. So I should probably just put that down here. So I had negative 41 over, and when you subtract fractions, remember you only subtract the top. The bottom, the denominator stays the same. So we have negative 41 over 16 is what we had here. So to move it to the other side, we need to add it, right? Opposite operation. So it's going to be 41 over 16 over here. Now we want to isolate x. So remember that means we want to square root this guy, square root that guy. And so when we square root this, we end up with x plus 5 over 4 is equal to the square root of 41 over 16. If this would have been a perfect square, we could have square rooted both of these, but because it's not, we want to leave it as is. And so now essentially what we need to do is just move this 5/4 over to the other side. So it's going to be x is equal to, we had positive 5/4, so it's going to be negative 5/4. And then just remembering that when we have a square root, it's always plus or minus the square root of 41 over 16. Okay, so this is great because it's being left in an exact form, but you might need to, if you want to confirm with technology, you're going to have to see on your graph what this number would be in decimals because your graph will read in decimals. So what you would want to do is in your calculator, sorry, I'll just make sure that's on the screen there, negative 5 divided by 4 gives us negative 1.25. Then we need to find the square root of bracket 41 over 16, which gives us 1.6. So basically we have negative 1.25 plus this value would be one of our roots, and negative 1.25 minus this value would be our other one. So these are our two possible roots. Now we want to graph and see if our graph verifies those answers. So go into your y equals and enter in negative 2x squared minus 5x plus 2. And look at our graph. And because we had number values, where did I just write that down? Oh no, it was kept in my other thing. So let me just have a look here. We had negative 2.8 and 0.35. It looks like that's going to be right, but let's just do a quick trace to make sure. So 0, left bound, right bound, guess. 0.35, so that one's good. And then do the same thing for the other side. Left bound, right bound, guess, negative 2.85. and that's the other value we had. So we've used technology to confirm our answers, and that's something that you can rely on for pretty much any question that you do in this. So that's a really handy tool to have for a test to make sure that you're on the right track with your answers. Okay, let's do one more example. This is going to be a word problem. So it's asking, how far does the soccer ball travel before it hits the ground if the trajectory of the ball is modeled by the function blah, 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 where x is the horizontal distance, right? So if we're looking for how far does it travel before it hits the ground, that's the horizontal distance. So basically that means we're solving for x, okay? Our units are meters, so we can kind of keep track of that for when we write out our answers. Horizontal distance from the goal line, and h is the height in meters. So our function is basically showing us how high the ball goes for each unit of horizontal distance that it travels. Okay, so like I said, we want to solve for x because we're looking for the horizontal distance. So if we look at this function, let's just write it out here really quickly. H of x is equal to negative 0.016x squared plus 1.152x minus 15.2. First thing we want to do is we don't want to have this terrible number out front, right? So what I would do for a question like this, first of all, is just to see if there's any chance that this divides nicely into these numbers, because if it does, then we're going to be really good for dividing that out and working with kind of like a better equation. So we have negative 0.016. Oh, whoops, I shouldn't have done that, because obviously we can divide this by itself and that'll leave us with 1, but we want to see if the other numbers will work. So 1.152 divided by negative 0.016 gives us negative 72. So that's a great number. Let's see if it works for negative 15.2 divided by negative 0.0116. 950. Great. So we have these nice full numbers. So let's just divide out that negative 0.016, and that's going to make things a lot easier. This side is going to be, I wrote an hx, but we're going to set it equal to 0 in order to solve it, of course, because remember we're looking for the x-intercept, so that means y has to be equal to 0. So we can divide that out by negative 0.016. And we're going to be left with 0 being equal to x squared plus, so when we did this division we got negative 72, so I shouldn't have put in a plus there then, negative 72x, and then when we did negative 15.2 divided by that we got plus 950. Okay, so now I have this much easier formula to work with, and so now I can look at starting to complete the square. Okay, so complete the square would be isolate these two, and my first step is that I want to find half of 72, which would be 36, and then square it, which gives me 1296. So I'm going to have 0 is equal to x squared minus 72x plus 1296. Okay, so just remember half of 72, 36, square it to get 1296. If I add in the 1296, I also need to subtract out the 1296 and then keep in the plus 950. Okay, now like I said, some of you guys might be comfortable enough now that you know that if there's no remaining a value that was being multiplied by what was in the bracket, then you can basically just bump this 1296 out in one step here so that we're not adding in unnecessary steps. So now I want to make this into a binomial. So essentially the square root of 1296, which we already figured out was 36, because that's how we got the number. So if we have 36, we need to figure out what values of 36 we'll add to make negative 72. It's going to have to be two negative 36s. So it's going to be x minus 36 as our binomial being squared. And then we can simplify these terms together. So negative 1296 plus 950 gives us negative 346. And so there's our equation, and then we want to start solving for x. So let's move this 346 to the other side. 346 is equal to x minus 36, oops, squared. And then I want to just use algebra to solve for x. So square root that, square root that. Square root of 346 is not going to give us a nice even number, so we're going to leave it as plus minus root 346 is equal to x minus 36. Then we can move 36 over to the other side, so basically it's going to be x is equal to 36, because we have to add it to the other side, plus or minus the square root of 346. Okay, let's see. Now the question asks us for the distance in meters, so we're not going to leave it as that. We're going to figure out the numbers. So square root of 346, 36 plus that value, or 36 minus that value. Okay, so that ends up being either 54 or 17 as our roots. So x is equal to 54.601 or x is equal to 17.398. So what students might think at this time is neither one of these doesn't make sense, right? Because they're both positive distances, which is what we would expect. So what you want to do is kind of visualize what's going on here. If we have these two roots, what's the graph going to look like? Well, we have an x-intercept at 54, so let's say somewhere out here. We have an x-intercept at 17. And we know that with a quadratic equation, right, because we have ax squared plus bx plus c, that means it's going to be a parabola. So it's going to be like this, right? So if you think about that in terms of a soccer ball, what would be happening here? Well, at this point, you would expect that the ball got kicked, it goes up and over, and then it lands here. So if we're looking for the horizontal distance, basically we want to know how far is it between these two points. And so then this is one of those times where we just have to find the difference because the start of the parabola wasn't at the origin at 0. So then we would need to say x for the horizontal distance traveled is going to be 54.601 minus 17.398, something like that. Make sure you keep your full values in there for your subtraction, because if you're doing a numerical response in a test and you haven't used your full decimals, like haven't rounded these off at all, you shouldn't be rounding these. If you haven't done that, then on a numerical response you could be off by a decimal, and especially when you get into 30 levels and write your diploma, you won't get the mark for that question if you're off by even 1 decimal. So that is why we need to keep our numbers through the whole time so that you get used to that for when you have to write your diploma. Okay, so now we're going to do, in order to keep all those numbers in, I'm just going to choose my exact answer, 54 minus 17, which gives me 37. So this is the point where I can round off my answer, 37.2. They didn't actually tell us to the nearest tenth of a meter, but I'm going to make it that. So 37.2 is the distance traveled by the ball. So again, look at the filled in notes for the proper written answer that I would expect on a test. So you should be saying 37.2 meters is the distance traveled by the ball. If you want, you can confirm this by inputting the function into your calculator and seeing if you get the same values. So go into y equals, and it's going to be negative 0.016 x squared plus 1.152 x minus 15.2. Go to your graph. Right, okay, so yeah, if we were at 54 and 17 to start out with, I want to reset my window because right now I have weird windows. So I'm going to make my x minimum can be 0. My x maximum should be, I'll make it 60. Okay, so yeah, there you can kind of see. And now if I wanted to, I could go in and trace my zeros. So for left bound, enter, right bound, enter, and then guess 17.39, which is what we had there. And then the second one, left bound. Sometimes wish there was a faster way to do this on these bigger parabolas. That, and then right bound, and we get 54.601, just like we had here. So you can see that your answers are confirmed in technology, which is great. And that's it for completing this square, doing some word problems with that. And next time we're going to look at using the quadratic formula. So that will be lesson 4.4, and I will see you there. In the meantime, just make sure that you do your practice assignment here at the bottom of the page. Okay.